الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone, this is Mais Alheraki of Flutter GDE, and I'm with you today to talk about platform channels and how to use native APIs in Flutter. Let's go straight to our talk today, and we are going to talk about first, what is a platform channel? Second, how to write a platform-specific code in Flutter. What does this imply? How can we do it? And all these things. And then what are the platforms and the native languages that we can use? Also, we will talk about the supported data types and the messaging codec. Then we will know how can we call an async method in both directions, from Dart to native and from native to Dart. We will also see how we can listen to events coming from the native side into Flutter. We'll also see an example on how we can call iOS and Android native APIs from Flutter. So let's start with what is a platform channel. A platform channels in Flutter, as you can see in this image here, you have your Flutter app. It's a flexible messaging API. It connects your Flutter with the underlying platform and makes you give you the ability to write messages and call functions from the native side and call Flutter from the native side. So it goes on both directions. First, we have our Flutter app. That's where we do all our Dart code and where we usually do our job as Flutter developers. But sometimes, and only sometimes, we need to touch into the native side. And that's where we use platform channels. As you can see, the iOS host does live in app delegate, and maybe you already have seen app delegate.swift if your app uses Swift in your on the iOS folder inside a Flutter application. That's where we can write our native code if we want and call the native APIs on the iOS side. And in the Android side, it's just the same. We have the activity, the main activity, which represent the Flutter view, and it connects to all the Android platform API. Like literally, we can call any Android API in any iOS API or any third-party API for Android or third-party API for iOS from directly and get the message delivered to Flutter. Now, third-party APIs that could include, for example, an SDK for some third-party service that doesn't have a Flutter package, a Flutter plugin already. You can do that, like wrap your that SDK with platform channels and then use it inside your Flutter application. We're gonna see how this works. Okay, so what is the possible ways of communication between my Flutter code and the native or the underlying platform? There are two ways. We either are going to call a method, like, call a method and then get a response. And that's done through the method channel class in Dart, right? And this is like a named channel, a channel that does have a name for communicating with the platform plugins using asynchronous method call. So what is the result that we get from calling a method in Dart? a platform channel in Dart, we will get a future of map or a future of a list or a future of dynamic, any type that could come from the native side. There's another way in which we can communicate with the underlying platform is by setting up listeners. And that's when there is some kind of listener of events happening in the native side, and we want to be notified whenever a new event fires, and we get the result in Dart, and we act like, set up a handler for that event and do whatever we want. And that's done using evented channels. Evented channels are just like method channels. They are named channels. They have a name for communication. And the result in Dart is going to be a stream. So you subscribe to that stream and it sends you all the results from native into your Flutter code. So how we write a platform-specific code in Flutter. Before we dive into native, let's see how we can actually write a platform-specific code without touching the native side directly in Flutter. Now, to write platform-specific code, that means you have some condition that you want to do, or a function that you want to call on iOS, and you have another function you want to call on Android. You don't want to call the same function on iOS and Android. For example, you want to return if you have an adaptive part of your UI, you're going to say, if my user is running the app on iOS, then show them this widget. And if they are running on Android, then show them this widget. This is possible using the target platform enum. Okay, we can know, and this target platform type is exists in the Flutter Foundation library directly. You don't need to call any third-party plugin or anything. It's immediately available into Flutter. And we can notice that target platform has all these values, like it has Android, Fuchsia, iOS, Linux, macOS, and Windows, but it doesn't have web. So how can we know if we are running on Flutter web? There's a constant called, like you can also call it directly, it's available in Flutter. K is web. It's a constant available in Flutter only. So if you are writing a Dart application, you're not gonna be able to use that constant. So Flutter runs on 6 targets: Android, iOS, macOS, Windows, Linux, and web. So to know which platform my app is currently running on from Flutter directly, we call default target platform. And default target platform is a getter that is already available. I can use it immediately from the foundation library. Let's see how does this look like. This example is taken from the generated Firebase options file from the Flutterfile CLI. And the Flutterfile CLI has different configurations for each platform. How do we switch the configurations based on the platform? We do that by calling default target platform. Let me get my pointer. So we do that by calling switching over the default target platform, and depending on the result, we return the desired configurations. Now, in case of web, we do the switch, like we do the check first. If it's web, just return web. If it's not web, then just go and see what platform are we running on. In case none of these platforms are supported, then we throw an unsupported error. In this case, Firebase options or the Dart, like Firebase packages support, does not support Windows and Linux yet, and that's why they don't exist here. And that's how I make sure that my code runs only on the supported platforms and uses the code I wanted to use on the desired platform. All right. So what about the platforms and the native languages that I can use if I want to touch into the native side? The native platforms on Android, we can use Kotlin or Java. On iOS, we can use Swift or Objective-C. On Mac OS, we can also use Swift or Objective-C, and we can actually connect iOS, like we can simulink the iOS code with Mac OS code. So maybe we can write only one code and it runs on both iOS and Mac OS. Also for Windows, we use C++, and for Linux, we use C. Using all these native languages, we can directly access all the native APIs on these platforms. So for example, if you want to run the third-party API that supports Windows, you can do that by using C++ to write a function, call that third-party API, and then call that function from Flutter using the method channel. All right, what about the supported data types? Now, there's some kind of communication that is happening between Flutter and the native side. And these messages that goes between Dart and whatever native language I'm communicating with need to have some kind, like there is that data types that's going on. Like I'm sending data and I'm receiving data. So what is the kind of data types that is supported? All these supported data types, we can already find them in the Flutter documentation. I'm just here posting an example just to show you. And later on, I will give you the link where you can check all the available data types. But initially, we say that a simple JSON-like type is used. That is, all the, in JSON, what are the data types that are supported? We have null, we have Boolean, integer, doubles, strings, these symbol data types that are supported. We can use them to send data to the native side, the native language, and get the results back. So in Dart, if I send a null, I'm going to receive in Java null, like the Java null, not the Dart null. In Dart, if I send a Boolean, I'm gonna get, like in Java, I'm gonna get java.lang.boolean. That is the Boolean in Java. And same for int, same for int. If 30 bits not enough, we get long. If a double, we get a double, string. Then we have unit 8, like down up to the map where we get a hash map in Java. So this is the Dart type and the equivalent native type. Now, how the kind of serialization and deserialization happen between these types on both platforms? It happens automatically. We don't need to bother with all these details that's happening in the lower level APIs. It all happens automatically. The platform channel API handles that for us. We just need to know what is the Dart type and what is the equivalent native type. And here's another example, Dart and C. For example, null in Dart, we get a G object of type FL value. All right. So how do we call the methods in both directions, from Flutter and from native? First, how do we call a method, like a native method in Dart? We first need to define a channel name. The communication happens on a channel, and the way we identify that channel is by its name, and that name is a string. In this case, you can note that the name is, and this is not mandatory, you can have really any name, you can put your name as a channel name, but we to avoid any interference that could happen, because since the channel is identified by its name, if you have two channels with the same name and both of them are receiving or sending requests and receiving responses at the same time, then there might be some conflictions happening, and you might get undesired results. So that's why we make sure that our channel name is always unique to that channel. We make sure that no other channel is using the same name. Of course, we use packages, we use plugins in our applications, and most of these plugins talk to the native side. They already handle some native job for us, and they use channels as well. So why are we saying here, like, we're putting the app name or the application ID as we have it in the iOS side or whatever, like you choose an application ID that represents your domain, and then slash the channel name. This way, most of the packages, if you go inside them, you will notice they follow a similar pattern where they first put the package ID slash the channel name. And the channel name can be like, we can have multiple channels in the same app or in the same package. This way, we ensure that our channel name is unique to our application. Then, after we have a unique channel name, we're going to define the channel itself. And that is a method channel. That's the class we're going to use, and we're going to pass the channel name to it. Now we have a channel. Cool. We define our result as a future of type int. Now, in this case, I want to, I'm expecting an integer to be returned. So I'm defining it as a future of type int result equals channel.invoke method. And this method has a name, get battery level. So I'm calling a method on the native side that has the name get battery level. And I can send any arguments I want in the form of, as we said, it's a JSON-like. So we have a key and value pairs. Next, we set, it's not next. It's actually like, this is how we define a method. That's how we invoke a method. We just invoke the method and we wait for the response. That's it, really. In Dart, that's all we have to do. But there is another case where we call a method, like we send a method from native, and we want Dart to expect, like to handle this method when it's called. So it's the other way around. In this case, we again are going to define a channel name, and we define a method channel class, but then you notice we are setting a method call handler. So I'm saying, if my native side, if Swift, if Kotlin have called a method with that name, in this case, I'm doing a switch statement over the methods that I'm expecting from the native side. If these methods were called, please do whatever. The default will be unimplemented error. Now, these are the cases. It's either I call it from Dart, I call a native method from Dart, or a native method calls my Dart side. In both cases, it's really easy, it's really simple from the Dart side. And channels and methods are identified by strings representing their names. So the channel name must be identical both on the native side, like on Swift or Kotlin, whatever language I'm using, and on Dart. Same thing for method calls. So if I'm calling this method on callback received, it should have the same name on native. So I am sure that I'm doing the communication well, and I'm expecting the correct result. All right, so that's on how we call asynchronous methods on both sides. An asynchronous method is just a request and a response. Nothing happens after that. But in case of events, streams, things that will fire up results in periodic time or whatever. So how do I listen to these events? It's simple. First, we have a channel name, again, the same as the method channel. And we define our channel. In this case, it's an event channel, not a method channel. And then we call the channel, I'm sorry, this is not events, it should be channel, it's just a typo. So we call channel dot receive broadcast stream dot listen. So we set a broadcast stream to listen on the channel that has this name. On the native side, I can set up an event channel as well, give it the same channel name, and set up a listener. And whatever is going on there, it's going to send the events back to my channel. And this callback is going to fire up whenever a new event is received. That's it. It's really simple. Not much code is going on there. Now there is another case. In this case, actually, we are setting the broadcast stream, but we need to make sure that our listener on the native side is actually set up to start. And usually when we do this kind of code on the native side, we set up the listener when on the first connection between, like when I first launch the app. But if I don't want to set up a listener when I first launch the app, I want to set up a listener when first the user, like the developer, calls and subscribes to that stream. I can do it this way. So first I invoke a method on the native side to set up some listener, that is a method channel. And then I return a channel name. And based on that channel name, I define an event channel. And that event channel is going to receive the broadcast stream and listen to it. So this way, I make sure that I only subscribe and set up my stream on both sides when the user or the developer actually starts listening to it. So these are some notes about the channel names. The logical identity of the channel is given by its name. That's what we said, that name, like identically named channel, will interfere with each other's communication if they have the same name and they send some result at the same time. There might be some undesired results. So if you have two methods that might be called at the same time in your app, make two different channels using different names. And if you have multiple native events in your app, like you have multiple events that you want to listen or subscribe to, you make sure to return a different name for each event channel to make sure that they do not interfere with each other's. Now let's see a real example on how we can call iOS and Android native APIs from Flutter. We go to the IDE. Now the code is already written, but I'm going to go over it and I'm going to show you how we can debug native code from in our Flutter applications. So this is, if I to make the font larger, this is a very simple application, and all it does is it gets the battery level from the native code. So it calls the native API on Android and iOS to get the current battery level on the user device. So let's see how first we have three tasks now. First, we're going to define the channel and set up all the code we need on the Flutter side. And then we're going to set up our methods on iOS, and then we're going to set up our methods on Android. And we make sure that both of them have the same behavior. So we are expecting on our Dart to receive the same result, both on iOS and Android. So first, we start by defining our channel. This is a method channel. I'm just going to call the channel one time, and I'm expecting to receive a result. So this is an asynchronous method call. And then I'm going to define a symbol string that is the battery level, and it starts by unknown battery level. I haven't called the native platform yet. Then we define a function, get battery level. Inside that function, this get battery level is going to be called when the user presses on the elevated button. Actually, let's start by running that. See the result. And then when I click on that button, I'll first try to invoke the method. That is, I call the channel, and because it's a future, so that's why I'm setting it as an async function, and I'm telling it to await for the result. And I'm expecting an integer to be returned as the battery level. Then I will invoke a method that is named get battery level. Okay, I'm sorry because this app is not gonna work on the iOS simulator. Sadly, I don't know why the iOS simulator doesn't actually return or simulate the battery level. It will forever be unknown. But it works on a real iOS device. Let's try that on Android. All right, and in case any platform exception happens, like an exception happening on the native side, I'm gonna get that. I can throw that from the native side, and I can act upon that mess by showing an error message to the user. All right, so this is all we need in the Flutter side. Let's see how we can debug and write the code on the Android and the iOS side. First, I'm going to start with Android, and I'm right now in VS Code. If I go to the Android folder and right click, I can open it in Android Studio. This is the app running. If I get on get battery level, it's going to say 30%. I can change that battery level from the emulator settings. Close, then I get the battery level again, and it changes. So it's working and communicating with the platform API. Now I opened my Android folder on Android Studio. Cool. If I go, like if we close here, we will see first, get that clean. We see the this is the latest version of Android. It might look a little bit different in older versions, but it's in the Project Explorer section, you will see your app. And then if you open the folder Java, you see this our application ID. And then we have the main activity. As this app, by default, Flutter application, new Flutter projects will use Kotlin for Android and will use Swift for iOS. You can actually change that and use Java for Android and Objective-C for iOS if you are experienced with either of them. And if I now the code is already there, but how it looked like before I add the bits of the battery example, it was just a class main activity with nothing inside of it. But after I added it, I will override the configure Flutter engine. That is the function that runs on when the application starts. So inside that function, I'm going first, of course, I'm defining my channel name, and note that it is the same channel name as I defined in here. So the same. We really make sure that it's the same. Any typo here could result in not getting any response back from native. So we defined the channel name, and then we override the configure Flutter engine. And in here, you know that we define a method channel, and that method channel is going to take a binary messenger that we can already have here, like it's already defined in this function, and we give it the channel name. And then we set a method call handler. Inside that method call handler, we will get a call, and this call, like this object, the method call, does have a method property, and it has the type string. That is the name of the method that I invoked from the Dart side. If we go back to the Dart side, that is the name of the method. I invoked a method with this name, and that's how I can get the result. I can say if the method called on this channel has this name, then do whatever logic I want and return the result using the result I have from the set method call handler. So I can either return a success result or I can return an error. And if I return an error, I will receive it in Dart as a platform exception type. Okay, so here in Kotlin, we are calling get battery level, which is a private function I defined that will return an integer. And in that, we have here some Android logic. to get the battery level API. I'm not getting the battery level from the Android API. I'm not gonna go over this code. It's a Kotlin code, but when you want to write some native code and you don't have prior native experience, and of course, if you are a Flutter developer, you must don't have a native experience, or you have a native experience in only one language, like you have in Kotlin, you have only in Swift, you have only in C, C++. You don't have that kind of experience in all these languages on the 6 platforms that Flutter already supports. So how easy it is really to write platform specific code. In here, we are just calling some logic. We're just interacting with some APIs and getting a result. We're not writing, any UI code. We're not writing all these things. So it's actually pretty simple. It's not that hard. And with like Googling and reading through the docs, you will discover that writing native code is pretty simple. I've already tried writing native code in multiple languages in Flutter, and it was really simple. Sometimes it takes me time to go through the docs and understand how things goes. Sometimes I go to the Kotlin docs, sometimes I go to the Swift docs, but in general, it's really, really simple and not that complicated. All right, so this is for the Android side. How can we debug? Like I wrote this code. I want to set some breakpoints and debug and see if the native code I'm writing is actually correct. I can do that actually by running my app on debug mode from Android Studio. This will help me debug the Android native code side of my application. So let's close the session running from the VS Code and run debug from Android Studio. I will set a breakpoint in here on the battery level. And I'll show you how we can stop there when I click the button from Flutter. And also I can maybe put a breakpoint here so we see the method call. Right, here we see it's connecting the debugger. We can get the console up so we can see all the messages. All right, so I have here 2 breakpoints. The first one is gonna stop when I call the method, and the second one is gonna stop when it returns the battery level. Let's try and click the button and see the result. It actually stopped on call.method, and if we see here the variables, like in here, the method call, we can see that the method name is get battery level. So that's how I'm debugging. If we go on to the next step, it called the get battery level function, and then it actually returned the correct battery level. Cool. So that's how we can debug the Android side. I will close Android Studio now, and will show you how to debug on iOS. Again, the same thing. I will right-click on the iOS folder, and I will open in Xcode. I'll just close my Android emulator now. And we will follow the same logic with Swift. We will define a method call handler, and then we will define our get battery function. Cool. This is the native part. Now, without all the logic about battery, it will look like this. Like without the method handlers and all these things, it will look like this. Right? That's what you usually see when you open your app delegate for the first time. And then you start adding your code bits by bit. Yeah. So in here, I defined a method call handler. And in that method call handler, just the same I did in Kotlin, I'm calling, like I'm checking if the call.method equals the same method name I've called from Dart. Then I'm going to send no, I'm sorry. It's actually, yeah, I'm not really a Swift expert. So I think it's guarding against the method not being this like get battery level. So it's sending a Flutter not implemented exception back to Dart and exiting the function. Otherwise, it's actually calling the receive battery level a private function, and this function is gonna just get the battery level using Swift APIs. So how I'm sorry, I couldn't really explain everything going on here in details. I'm not a Swift expert, I'm not a Kotlin expert, but in general, we can get the common sense and understand what's going on here. Uh, yeah. All right. So how can we debug our iOS side code in from in Flutter? We can do that by simply just pick any simulator you want here in Xcode. For example, I'm going to pick the iPhone 12 and then click on Run. And I will again set a breakpoint in here and on the call method handler. Cool. Now the app is running. If I click on Get Battery Level button, it will first stop here. And if I just let's see the result in here. Think, yeah, it's in the call. And then we have the method that has the type string and it's Get Battery Level. And I'm expecting it actually to stop here. Let's go. Yes, it stopped. And then it will stop here. It will stop. Yeah, it will not actually stop here because it never returns the battery level on an iOS simulator. Yeah, it will not stop. It will actually stop here and return a Flutter error. Battery not available. So it returned a Flutter error, and on Dart, it executed this part. It catched a platform exception. So that's how we can debug the iOS side. With this, you can actually call any third-party SDK that supports iOS and Android from your Flutter application. You can call any native APIs, and you can debug them using Xcode and Android Studio so easily. You don't really need to worry about if there is a package that does not exist in Flutter, or there is a native API that you need to call. It's really easy. It's not scary, and I really advise you to go and try to, if you haven't before, to go and try doing it yourself. Try it with iOS, try it with Android, and see how you can call the different native APIs in Flutter. It's really fun. The first time I was always scared of doing that, but then the first time I did it, it turned out to be really simple and easy. With this, we finished our talk for today. I hope you all enjoyed it. Thank you very much. And as a last word, everything I've talked about today is already on the Flutter documentation. If you want to learn more about platform channels and how to use them, you just go to this page. It has a comprehensive guide on everything you need to know. Also, if you want to do a plugin, like a package, a different package than your application that does wrap some kind of third-party API that you need in your app, you always go to this guide on how you can develop packages and plugins, and it will tell you everything you need. Thank you again. I will see, do we have any questions? Stop sharing now. All right, we have a question here from Firas. Any use case of the event broadcast? I assume you mean the event channel. So yes, event channels. For example, in our example, the battery example, you can there's a listener that listens to the the status of your charging. Like, is your uh, phone now charging? It's not charging. What's the status of your charging level? Or I actually forgot the exact stream, but there's this stream on Android and iOS. We can set up an event channel. And actually, yes, I forgot to say that if you want to see some really good examples and actual use cases of method channels and event channels and how to do different kind of stuff, I advise you to go and check some plugins that, like battery. There's a plugin for battery. It's a very good plugin. I might maybe share the repository so you can take a look at them. So in that plugin, there is that event channel. We set it and listen to the stream about the status of the current status of my charging, of the user charging or the mobile charging. So yeah, there's different kind of use cases. I will share the Plus plugins. Now, Plus plugins is a very good example on how you can write native code. Most of the plugins in the Plus plugins does support all platforms. Like, it really has all the native code and on the six platforms. So you can go and check the source code and see how different API methods are being called in Dart. See if we have another question. If I want to contact it someone is asking if I want to contact it with IP, how to do it. I'm sorry, I didn't quite get what you mean. If you can elaborate more on it. Yes, this is a very good question from Muhammad Jalal. Do we need to clear or dispose the channels? Now, you don't really need to do this, but in case you are setting up some listeners, you need to clean up your listeners. So on dispose on the native side, there's a method called when we kill the Flutter application, so you can clean up all your listeners. Or you can, there's different kinds of how you do cleaning on the native side. I don't really know how to do it. I know how to do it, but I don't remember the names of the methods on both iOS and Android. But in general, yes, you need to clean up your listeners and resources just as you do normally. But for the channels themselves, no, there's nothing like that. All right. If you have any questions, we do still have time. Thanks for your comments, Muad. Okay, I hope I didn't miss up things because I'm still also new to many topics and things in the native side from Flutter. It takes time and practice. I really advise you all to do not be afraid of it and go and try it. It's easy, it's simple, and it gives you more power in Flutter. Thank you everyone for attending today, and see you inshallah in another talk.